Okay, today we're going to be talking about how to make threads, such as the threads on nuts and bolts and screws. This process comes to us from George Russi at Creative Gold in Philadelphia. Thanks so much, George. This is a really trick method. So we're going to work in our matrix field. First thing we're going to do is grab a line. I like to use U04 as one of my base colors to work in, like base layers. And I'm going to set it up as 1mm grid. I'm going to make a line that's 10 millimeters long, 1 centimeter, because most metrics threads are based on 1mm increments. We're going to work with this. Go up and get our helix tool. Start of axis is going to be right here on the left side and ends on the right hand side. Now the diameter I've already put in is 5 at the top up here, but we'll go ahead and put 5 in again just to show you how that would be. You put in 5, you hit the enter key, and then you right click. Or I'm sorry, left click. And now we have a 5mm diameter coil. We have 10 threads, or in other words, 1 coil per millimeter. But we've only got the outside edge of the threads, and at the moment all we got really is a helix. I'm going to change that over to my user 02 layer because I want that to be my primary outside helix. Going back to user 05, I'm going to turn on my quad tool, and I come up here to quad, and I'll go straight down almost the center, just something like that. And there's a line. First thing I'm going to do is I'm going to rotate that line by 30 degrees. So I'm just going to type in 30. The reason I do that is most standard threads are 60-degree threads. Now we're going to mirror that off the same point. And as you can see, there's where my threads get started. The next thing I'm going to do is I'm going to grab those, and I'm going to copy them from this quad point over to that quad point and over to that quad point. That gives me some crisscross points to work from. The reason I did that is now I'm going to take my line tool. I'm going to go where I have intersecting lines, turn off my grid, and there we have it. And the reason I did that is I have to pull this model down and make it smaller and then shift it over so that I can build the bottoms of the threads that we're going to work from. So the next thing we're going to do is we're going to shrink this down to this size right here, down to that tip. So there's a center, and that's what we're going to want to work off of. We've got a quad, we've got a center. Let me zoom this up so you can see what we're doing here. I'm going to shrink this coil while copying it. Let's try doing it in user 01 layer. We're going to come up to 2-dimensional, scale 2D. We're going to copy. The origin point is going to be F4. That's why we're working here in the middle of things. We're going to come up to that midpoint, and we're going to shrink it down, but not in that field. We're going to shrink it down until we hit the mid of all these other lines, and that's going to be tricky to do. So the best thing to do here is to turn these guys off. Just hide them. Boom. Now we got our little line there. We'll do this again. We'll go like that. We're going to do a 2-dimensional scale with a copy. We're going to start there. We're going to come up to our quad point. And now we're going to come down until we find the midpoint of our thread. Boom. There's our midpoint. All right. Well, that's no good because that's not the way threads are built. So what we're going to do is we're going to move this. We're going to copy it off of the quad to the end. And we're going to go quad point, end 1. And I'm going to take that one and change it to user 01 red. And then I'm going to copy this one. And I'm going to move it to that point. And now I'm going to delete my first one. And I'm going to take my second red one. Excuse me. And I'm going to make it user 03. So that I have user 01 starts out here. User 02 comes up here where the top of my thread. And user 03 starts down there. There's my 3 threads, okay? That's how I'm going to establish my thread. And this is the cool trick that George showed me that's really neat. Pick a layer. I usually use metal 01. We come up here to perspective. We have our history on, and we're going to loft. We're going to come into solids. We go to loft, and then I like to loft off of the tips. So I go loft from there to there, and then come back down here, and that caught the blue one. And we hit the button, straight sections, closed loft. There we go. We could have left it as an open loft. Probably would have been the smarter thing to do. Go into a closed loft. There it is. You just made some threads. Now you've got to cap it, cut it off, and all that sort of stuff. But there are your threads. The reason this is so cool is watch what happens. We can actually shrink, move things around, do all kinds of stuff. So I'm going to grab my outer curve, come down here. Oops, it's too large. Okay, we're going to go for a smaller diameter. Well, we'll just scale it 2D. Come on here like this. Shrink it a little bit. We wait for history to move it, and boom. And now the angle that we're at no longer matters. That's the cool trick from George. So if your threads are not a standard 60-degree V thread, you can adjust these to make anything you want. And you can move these from metric to English sizes simply by scaling it. So all you really need to do is make one of these and put it in your job bag, probably in your tools job bag if you have such a thing, and you're off and gone. Now, having shown you that, let's talk about something else. I happen to use Mozilla over Internet Explorer. Just happens to be my personal preference. But one of the resources that we have on the web is McMaster-Carr. And I'm going to just type www.mcmaster.com. This is a company out of Chicago, Illinois. They do not trade internationally or into Canada. However, they are a huge supplier of pieces and parts. What I'm going to do is I'm going to type the word bolts into their product finder. And one of the bolts that we use a lot of around here at Gem Vision are socket heads, or Allen heads as we call them. So we'll go socket cap screw. Now let's come down here, we'll pick our material. Okay, our material today is going to be steel, just for giggles and grins. It's going to be a standard head size. And we can come down here, and as you can see, we have all of the American sizes all the way up to 3-inch, 4 threads per inch, and we have all of the metric sizes. Metric 1.6 all the way down. Let's go back to our metric 5 buddy that we just were building. But here we have a whole one. Now, locking method, none. We don't need a nylon patch. We come down here and we have all kinds of part numbers. These are McMaster-Carr part numbers over here on the side. You have Deutsches International Normen, which means German International Normal, which is their standard. They have ISO, which is the international standard. And then you also have ASME, which would apply to American size. Let's go up here and we'll say, length. Oh, what the heck. We'll go with a standard 10mm cap screw. Nothing fancy. As you can see down here, McMaster-Carr very nicely provides us with a engineering diagram of the part, but they also have up here where it says download. This is the cool thing, guys. You come up here, you go to download, you go to step file. This information comes to us from Bob Marino in the design department at Gem Vision. What I'm going to do is I'm going to save that step file, and it's going to come through as the part number .step. So we'll go ahead and save that, and it's a little tiny file, 425 kilobytes. And if I close out of this, I will find that there's my step file on my desktop. Okay, one of the cool things you can do with step files is we'll shrink this down. We saved it, right? No, of course we didn't save it. Merv knows how to build these things anytime he wants to. Let's go ahead and save that thing. Control A, save it. Now we can wipe it out. Goodbye. Here's our step file. Drag and drop it over here in Matrix. Step files are 3-dimensional files. They're files that we can open up. Now, here we have a 10mm by 5mm cap screw. Came in the lights layer, no problem. We go ahead and change it over to Metal 01. This is a perfectly good, workable, matrix modelable part. And as you can see, it's all there. Hex, the hex hole, everything. This is a very well modeled, has all the spacing that normally would occur on a metric thread. They don't bring them to a point. They're actually flattened off. This is a stock and trade, ready to go screw. So if you're designing something like a watch case or something like that, you can go to McMaster-Carr and find standard DIN, ISO, and ASME threaded devices, bring them in as step files, and use them directly in your modeling. No need to go and build this thing, which is about a half an hour worth of work. Somebody already did it for us. So everybody enjoy.